Okay, so we're looking at the other category of matter now. So remember, we can have a pure substance or we can have a mixture. So a mixture is where you have two or more chemically not chemically connected types of particles. So you can have, let's say, a small and big particle. They can be different colors, different shapes when we're drawing particle pictures. In real life, of course, they would be different molecules or different compounds. So the key is you have two or more different things inside of that part of matter. So that is different from when we look at connected particles, right? So this would be a pure substance because they are the same type of particle that it's connected on repeat. Here you have two different particles. Okay, so mixtures can be separated further into homogeneous and heterogeneous mixtures. Now, the difference between these two is the visual, like looking at it visually, what type of mixture it is. Homogeneous appears to be one visible phase. So what that means is it looks like it's one thing. You cannot see the separation of the different particles. So for example, tea, coffee, Kool-Aid mixed, and we're talking about already mixed with water here, of course. Hot chocolate mix, air, right? Air is a mix of different gases. When you're looking at it, you cannot see the differences. I can't look in a room and the air in the room and say, okay, well, this pocket of air is nitrogen and this pocket of air is oxygen, right? It just looks like a colorless gas. So one visible phase is homogeneous. This also goes by another term which is called a solution. So the word solution and homogeneous mixture can be used interchangeably. Heterogeneous is where you can see a difference in the phases, so two or more. So some examples, right? Oil and vinegar, we can see the oil part, we can see the vinegar part, sand and rocks mixed together, orange juice with pulp, so we can see the pulp portion and then the juice portion, looking at a whole bunch of different things. Salt and pepper, right? You can see the salt particles and the pepper particles. When you can see a difference, it's a heterogeneous mixture. When you cannot see a difference, it's a homogeneous or solution. Okay, so heterogeneous has further definitions or further separations, I should say, and that typically has to do with the type of mixture that you can see the change in. So a mechanical mixture, so I usually use MM for short, a mechanical mixture is usually where you have at least one component made up of that mixture being a solid. Okay, so mechanical mixtures are very easy to separate. You can either separate them with instruments, even with your hand, right? So let's say I have Raisin Bran cereal and I want to take out the raisins. I can do that pretty easily. Or if I'm eating a slice of pizza and somebody has mushrooms on it and I don't like mushrooms, I can take the mushrooms off. But even filtering or settling or separating with magnets. So for example, orange juice and pulp, let me go back to this picture for a second. This is separation by filtering. I can take the pulp out by running the orange juice with pulp through a filter. So the filter will basically catch all of the pulp and only the juice will run out. So orange juice with pulp would be classified as a mechanical mixture, right? So the general category is mixture. The next sub-level would be heterogeneous mixture. And then because we can separate it relatively easily, because it has a solid component in it, it would be a mechanical mixture. Okay. A suspension is typically things that are not easy to separate. So usually these involve gases or liquids. So for example, smoke in air, right? So you can see the difference when there is a cloud of smoke, even if you were to look, let's say there's a fire happening, campfire, and there is smoke in the air, you can see the difference between when there's smoke and when there's no smoke. But you can't separate it. I can't take a net and catch all of the smoke inside of a net. Okay, it's hard to separate because they're gases. Oil and vinegar, right? Hard to separate because they're both liquid components, right? So mechanical mixture, usually you have something that is a solid that you can remove easily, whereas a suspension, it's not very easy to separate. Now, the Tyndall effect has to do with suspensions. I'm going to add a video clip of what the Tyndall effect is all about, or I might actually show you. I haven't decided on that yet. There'll either be a video clip or I'll show you in class. But basically, the Tyndall effect is where you have light particles that are scattered. Now, how this works is usually where you have a liquid and you have a fine powder in it. Okay, so the example we usually use is starch. So you're probably thinking, well, if it's a solid, it's a powder, you can separate them with a filter. But suspensions can sometimes involve solids, but they have to be so fine that basically it can't be stopped with a filter. Like it goes through the filter. Now, when you are told you have a solid and a liquid, you should be assuming you have a mechanical mixture, okay? Suspensions that involve solids are very rare. So we use this as an example just to show you what a suspension is, but it is not common, okay? So I don't want you assuming that if I tell you you have, sugar, I have sugar particles in something, or that's a bad example because they dissolve, but let's say I put sand in water, right? So I'm going to put sand inside of water. It's going to be a mechanical mixture because I can still separate the sand from the water, okay? So starch is one, like a very specific example that does this. Not many other things do. So what happens is the starch is basically floating. Think of the word suspended, right? It's kind of floating in the water. And what happens is when light particles are shone through it, it kind of scatters it. So some will go through, some will reflect out, some will bounce out. But basically you have these little tiny particles that are causing the light to bounce around inside of that material. So that's called the Tyndall effect. Okay, so suspensions either involve gases or liquids. Sometimes you'll have a Tyndall effect where you have it with starch. Very few things will do this. But anyways, it does categorize as being a suspension because it is difficult to separate. Okay, so homogeneous mixture, as we mentioned, is one visible phase, and it's also known as a solution, right? So this is why it's interchangeable, because really there's only one type of homogeneous mixture, and that is a solution. So if I tell you we have a solution of sugar and water, that's automatically a homogeneous mixture because of the term solution. Now, solutions can also involve solids dissolved in other solids. Okay, so for example, an alloy. So the term alloy means that you have a mixture of metals that have been essentially melted down and mixed completely together. So for example, so it's two or more metals that have been mixed. So for example, your bicycle frame, or a car, the metal that's made up for a person's car or the bus or airplanes. Metals are very rarely used in their pure form for when you are buying and selling products or vehicles. The reason why is because different metals have different properties. So by mixing metals together, you can reduce the cost, of course, and you can also get the properties of more than one type of metal. So for example, an airplane or even your bike is usually an aluminum alloy. So the reason why is aluminum is a very light metal compared to other metals anyway. So the aluminum will give it the lightness so your bike doesn't weigh 100 pounds. But you do need other metals such as iron or lead to try and strengthen the bike. So that way, think of a bike made of aluminum foil, right? If you sit on it, it's probably just going to collapse. It's not going to hold a person. So you have to add in different metals to have different properties. Okay, so you can still separate solids dissolved in liquid here, but you can only separate through evaporation, right? So imagine if I have salt dissolved in water, the only way to separate them again is going to be if I remove the water. That way I'm left over with salt at the bottom of my beaker. There's no really other way of doing it because they're they're mixed together so well, right? It's one visible phase. You cannot see a separation. Okay, so we're just going to play a short little classifying game here. So it doesn't separate by mixture, just, it doesn't separate by heterogeneous, homogeneous, but it's just as more for fun. So we have some compounds, some things here, not compounds, but we have carbon dioxide, which is CO2. We have silver, we have lemonade, oxygen, NaCl, which is salt, shampoo, air, and pure water, which is H2O. Okay, so pause the video. I want you to think about where each category, where I should slide these two. So if I should put, there's more underneath, but we're going to do the ones on top for now. If it's an element, a compound, or a mixture. Okay, so let's take a look. So oxygen should be an element. Pure water, H2O, is a compound. So is carbon dioxide and sodium chloride. Silver is an element. Lemonade, shampoo, and air are mixtures. So we have here 2, 4, 6, 8. Yeah, so here's the next set. So the next set we have, so soda, so just like pop. We have helium. We have hydrogen, carbon, Rocky Road ice cream, which is an ice cream that has marshmallows and chocolate chips in it, copper, gold, glucose is C6H12O6, if you remember that from photosynthesis. Okay, so pause the video, give these next 8 a try. Okay, so soda, oops, oh my gosh, I'm writing. Soda should be a mixture. Hydrogen is an element. Helium is an element. Gold is an element. Carbon is an element. Glucose should be a compound. Rocky Road ice cream is a mixture. And copper is also an element. That'd be really embarrassing if I went to check those and then some of them were wrong. So remember that these mixtures could be further divided, right, into mechanical mixture or, heterogeneous or homogeneous, but just for this small little short activity, we're just looking at the 3 here. So when you are doing your worksheets and stuff, we'll go over more and more examples. Try not to be too specific. So what I mean by that is, for example, soda or shampoo. So shampoo, we're talking about the general term of what shampoo is. So some people have shampoo that have like little particles in it, like little beads or something. So just think of things when you're doing your worksheets and your homework for this as just in general, like the most common thing. So the most common form of shampoo is usually just a liquid that's one color. Because everyone's going to have a whole bunch of different examples from their own real life experiences, right? So just trying to think of things as general.